So what we need to talk about mainly, and this will actually take you up to the edge of calculus. So I know two of you are taking a calculus course. Has anyone else had any experience in calculus?
No. We've had pre-calculus and that's it.
Okay, so you probably have seen this if you've had a pre-calc course. But there's basically in introductory calculus, two things you look at: differential calculus and integral calculus. And the two are actually tied together with something called the fundamental theorem of calculus. At the end of the day, calculus ideas are not that difficult. They're, but it's the algebra you have to bring, which hence is why you take a pre-calc course. You have to be really solid in your algebra in a calculus course. Typical calculus problem, say it's 10 lines of work, 2 of them are calculus and the rest is algebra. So what we're going to look at today is something called difference quotient. All right, so what I'm going to do is, if I'm going to, for a function y equals f of x, the difference quotient is f of x plus h minus f of x all over h. So highly original name. It's a difference in the numerator and you're dividing by h, hence quotient. You guys seen this before?
I don't think so.
Okay. Now this kind of looks like, kind of complicated, but at the end of the day, it's a slope. It's a slope of a line. That's all it is. And so what I'm going to do first is just explain what this is exactly. So I'm going to try to draw a vertical line here. All right, so let's say we have some function. So here's just a average ordinary function. Right, so let's say we have some value x. Right, some number here we're going to input into a function. Then the corresponding point on the graph of this function would simply be x and then its functional value f of x, or the y coordinate. Now let's say we move from x here h units. So let's move over h units. So this would simply be whatever that value x was plus the number of units I moved h. So h is just some number, and its corresponding point would be inputting x plus h, and then the y coordinate would be f of x plus h. Now, between any 2 points, there is a line, if I can draw it. Okay, so if I said find the slope of the line, so that's going to be the ratio of the vertical change over the horizontal change, corresponding horizontal change. Rise over run. In terms of calculating it, it's simply going to be difference of the y coordinates over difference of the x coordinates in the same order. So if I look at these 2 points and I said find the difference of the y coordinates, I'm going to go in this order. It's going to be a f of x plus h minus f of x. In the bottom, we're going to have x plus h minus x. then those two are going to subtract to 0, leaving me just with h. And so this difference quotient, again, is nothing more than the slope of a line through 2 points of that function. And that's all this is. Now, you're going to note that, like, say if I decreased h, made it smaller, then that point, corresponding point here, is going to move, we're going to move in this direction, this way. And so notice that each time I'd make h a little smaller, the slope of that line is going to change. And if I kept making h smaller and smaller and smaller, what number would I be approaching? What would h be approaching? If you keep making it smaller and smaller and smaller, you're headed to what?
0.
0. When you had some pre-calculus, did you ever look at something called a limit?
Yes.
Yeah.
Okay. So the way you would actually write this, and if we were actually starting a calculus course, we would spend a week or so just talking about limits and finding limits and whatnot. And notationally, it looks like this. You are LIM, and I'm going to say h arrow to 0, and that what that means is h is approaching 0. And if you find the limit as h approaches 0 of this difference quotient, this is not something you need to know for this class, but again, it's a preview of where you would be headed with calculus. That is what we call the first derivative of that function f. It's a separate function, but it's a derivative function. And what that exactly is, when you take that limit as h goes to 0, and this point gets here and here and here, eventually that line is just going to hit that one point. And that's what we call a tangent line. And the slope of that tangent line, that's exactly what the derivative is at that point. So, so again, we're on the edge of calculus right there. And kind of putting that idea into real world context. If you would, if I would drive, let's say 15 or so miles, and I averaged, let's say I was driving through town and I was averaging 95 miles an hour. So did I go 95 miles an hour every moment of that trip if I'm driving through town? Hopefully not, because I'd be a madman, right? You got stop signs and stop signal, pedestrians, you're going to have to be slowing down. So at some point you're going much slower, some points you're going much faster. And what the derivative is at that any one point along that interval is what we call the instantaneous rate of change. This difference quotient is what we call the average rate of change from that point to that point. So our goal here in working with this is simply to look at the algebra involved in finding the difference quotient. And then you go from there into calculus to take that farther. So that's what we're going to look at. So you're not going to be tested on, all this, just the algebra and finding a difference quotient. So I'm going to turn the page and start with a linear function. Let's say I have f of x equals 3x plus 2. And I said, find the difference quotient. Now, think this one through, see if you can make the connection. If the difference quotient is the slope between any 2 points on the graph of a function, the slope of the line going through any 2 points of some function, what would I have to get as an answer if I take the difference quotient of this function, 3x plus 2?
Would it be 3?
Yeah, 3, because it's a linear function. So the slope for a linear function never changes between any 2 points. So it has to come out to be 3. So when you do the homework, just realizing that you're going to be given a linear function asked to find the difference quotient, you can bypass all the work and just find the slope of the line. And that's got to be the answer for that particular function. Now we're going to go ahead and work it out and show that we're going to get 3 here. And then we'll move to other functions that won't be the case. So what I'm going to do first is for this function here, I'm going to find f of x plus h. So into my input, I'm going to put x plus h. Now the difference quotient is f of x plus h minus f of x and then all over h. So I'm going to put that together now. Here's my, and I'm going to go ahead actually before I do that, just distribute the 3. Okay, so difference quotient. It's down a little bit. Shoot. Difference quotient. F of x plus h, so 3x plus 3h plus 2 minus f of x. F of x was 3x plus 2, so that there, all over h. Now, so algebraically, when you work these, what is the end game? What are you trying to get to? You want to get this value h in the bottom to cancel out. So that is, so no matter what function you're finding a difference quotient for, that's the end game. You want to get this guy to cancel out in the bottom. So basically you could let h be 0 and not be undefined. Right now, if I let h be 0, I'm dividing by 0, so no good. All right, so I'm going to distribute the negative sign because I can do that. So minus 3x minus 2, still all over h. And then notice any term that didn't have h in it has an opposite. They all drop out, leaving me just with one term, 3h. And now I can legally cancel out that factor of h in the bottom, leaving me just what we knew the answer had to be, 3. Any issues there? Okay, so let's look at something that's not linear. Let's say we have a function f of x. Let's make this one 2x squared plus x minus 1. Now, that graph is definitely not a line. It's a quadratic function. Its graph is a parabola. So between any 2 points on the graph, that slope is always going to be changing. So you're not going to get just a single value. You're going to get an expression involving x and h. But process-wise, I'm going to do the same thing. I'm going to first find, let's just find f of x plus h. So for this one, it's going to be 2 times x plus h squared plus x plus h, and for that input, and then minus 1. So I'm going to go ahead and multiply this out, combine like terms if I can. So x plus h squared would be first term squared x squared, product of the 2 double 2xh plus h squared. And then I'll have to distribute that too. So I got plus x plus h minus 1. So I'll distribute to 2. That's going to give me 2x squared plus 4xh plus 2h squared plus x plus h minus 1. And there's no terms that I could combine. So that's it. So putting it now in the difference quotient, we'll have our f of x plus h. So all that again, 2x squared plus 4xh plus 2h squared plus x plus h minus 1. Now minus f of x. So that's, here's f of x. So this time, just to save a step. I'm going to go ahead and distribute that negative sign through here, which would be minus 2x squared minus x plus 1. And all this over h. Now, what you're going to notice again, just like on the last one, every term that doesn't have a factor of h is going to have an opposite. I've got 2x squared, I've got negative 2x squared. I've got positive x, I've got negative x, I got negative 1, I got positive 1. So I'm left with 3 terms up top, but each having at least one factor of h. So I can factor that out, these 3 terms. So factoring out that one factor of h, that's going to leave me with 4x plus 2h plus 1 all over h. So remember, the end game was get that h in the bottom to cancel. So these two guys cancel out, and I'm left with 4x plus 2h plus 1. Now, and again, this is that, and that would be your answer right there. That's what you would input. You'd say that is the difference quotient for that function. So taking that just a step further, looking at if we were working a calculus problem, if you let h be 0 now, you would be left with 4x plus 1. And notationally, the first derivative of this function is 4x plus 1. How many of you guys are looking at a degree that's going to require calculus when you get to college? Or do we have an idea?
I don't know.
Not sure. Depends on what, you know, if you go in any kind of engineering, you're going to take calculus for sure. If you, certain business programs are going to require calculus. So if you take a Calc 1 course, you're going to spend that first few weeks learning how to find a derivative by the definition and doing all this heavy algebra. And then your instructor is going to walk in one day and say, hey, guess what? We have all these cool shortcut rules. Then you're going to get upset. Like, why didn't you show that to me in the first place? But we want, you know, when we teach a calculus course, we want to go right into what is the definition of derivative and do it this way. Just make an observation here. This has a power of 2. The power rule says take that down and multiply it by the coefficient and reduce this by 1. Notice if I do that, I'm going to get 4x. And this would have a what? Exponent of 1. Well, it drops down here. I've got 1. And reduce that power by 1, you're going to have 0, and anything with 0 power is 1. So you end up with 1 times 1, which is 1, or the derivative. It's called power rule. So you literally can go with using those rules from here to here and bypass all this, except when you take a test and have to show all the work. Anyway, any questions on that? All good? All right, well, let's do another, just because I know what's coming up in the homework. Let's take another function. Let's change the letter just for the heck of it. Let's do g of x equals, let's see, 4 over x plus 1. So this is going to be a rational function. And let's say we wanted to find the difference quotient of this one. So as before, I will go g of x plus h. Now here, the input is simply right here. So that's going to be x plus h plus 1. That's it. So putting this in the difference quotient, you're going to have 4 over x plus h plus 1 minus g of x, which is 4 over x plus 1 all over h. All right, so there's the difference quotient. Now, in game, we want to what? Get this to cancel out. So unlike before, when we looked at that quadratic function, what in the world can I do here? So because there's nothing to multiply out here, you don't see, it's not like get the terms to cancel out and be left with every term having a factor of h that I could factor out and get that to cancel. For a rational function, the algebraic technique is to simplify this complex fraction. Complex fraction is simply one that has a fraction in the numerator and or denominator. So that's the algebra we're going to have to do. So to simplify a complex fraction, the easiest way is to find the LCD of all the terms, least common denominator, and then multiply top and bottom by that. So here, the LCD is x plus 1 times x plus h plus 1. And as long as I multiply top and bottom by that, I'm just multiplying by 1. So we're good. Now, this one, I've got 2 terms up in the top. And understand you can think of this as being, over 1 and distributing it in. That's going to eliminate the complex fraction because you're going to get these denominators to cancel out on the top. So when I distribute through here on the first term, I'm going to get the x plus h plus 1s to cancel out. And I would be left with 4 times x plus 1 minus. And then distributing onto here, I get the x plus 1s to cancel out. So I would have 4 times x plus h plus 1. Now on the bottom, distributing to the bottom, nothing cancels. You're going to have h times x plus 1 times x plus h plus 1. But the complex fraction is now gone. Now from here, kind of the same thing's going to happen. Here. It's going to be distribute to 4, distribute the -4 here, and we're going to get everything to cancel that doesn't have a factor of h in the top. You would have 4x plus 4 minus 4x minus 4h minus 4. And I've got to write all this again. H times x plus 1 times x plus h plus 1. But notice I got 4x there, -4x. I got 4, I got -4. And I'm left with a -4h in the top. Over all this stuff again. But goal accomplished. I get that h to cancel in the bottom. I could now let h be 0, and I'm not going to get 0 in the denominator anymore. So my final answer here would be -4 over x plus 1 times x plus h plus 1. And that would be the answer you would input. Now, again, kind of taking this to calculus, if you let h be 0 here, that is, take the limit, you would have -4 over, letting h be 0, you would end up with x plus 1 times x plus 1, which you could write as x plus 1 squared. And that would be what we call the first derivative of that function. That's just taking that a step further. All right, any questions on that one?
No.
Okay. All right. Writing that down. All right, so the only other thing in this section, and there's only honestly one problem even dealing with it, but and it's a simple idea. It's what I call the algebra of functions. The word algebra itself basically means looking at the four basic operations, that is addition, subtraction, multiplication, division, on a set of numbers. So the algebra of functions is looking at what would be, say, if I had two functions, what would that be? And it's simply, like you would hope, add the two functions together. So, and then it would follow suit, say for the difference, you would subtract the two functions. Remember to distribute a negative sign. Product, simply be multiply the two functions. Now, in all these cases here, as we're always from here on out, here forevermore, given any function, we're always going to be interested in what its domain is. That is, what values can I plug into the function and get an output which is defined. So in all three cases here, you would look at the domain of each of the two functions and simply look at what they have in common. And that would be your domain of this new function. One I haven't done yet is quotient. And with it would simply be f of x divided by g of x. And you would have the same idea, find the values that are common in the domain of each, and that would be the domain of this new function. But you have to also look at any value you plug into g, which would give you an output of 0, and toss it as well, simply because you can't divide by 0. And there's, I think it's number 7 in the homework, specifically deals with this right here in terms of its domain. All right, any questions? All right, so that is 3.1. And so I'm not going to go into 3.2 today. I'm going to wait till Tuesday on that. So the hope is everyone will have worked through 3.1 and barring any questions you may have on some particular problems, which we'll take up first thing on Tuesday. And I will cover 3.2 on Tuesday. I didn't get that. I was going to get a video assignment in for 3.1. I just realized I hadn't done that yet. So I'm going to do that right now. So it'll take a couple minutes. I've got to import it from another class, but I will do that right now in case anybody wants that. So let me